Welcome to Maki Study Circle channel. In this video, we shall see how to do the computer drafting of the isometric projection of the combination of solids. In this problem statement, we have a cone of base diameter 30 mm and height 40 mm, which is resting centrally over a cube of side 50 mm. We need to draw the isometric projection of the combination of these solids. So here we need to observe two things, that is, the type of solids that is given to us and also the way in which they are resting on each other. So here we have got the combination of solids as cone and a cube. And the parameters defining the cone is the base diameter of 30 mm and height of 40 mm. And also a cube which is having all the edges equal to 50 mm. And the resting condition is a cone is placed on top of a cube and such that the axis of the cube and the cone are collinear or they're concentric. So now we need to draw the isometric projection of the combination of these solids. So before we draw the isometric projection, let us draw the orthographic view of this combination of solids. Select a line of thickness 0.18 mm and draw the XY line. Now select a line of thickness 0.50 mm and then we shall consider drawing the top view of the cube, which appears as a square of side 50 mm. So this is the top view of the cube. So on this cube we have got a cone whose base diameter is 30 mm and the height is 40 mm. But however, in the top view we get to see only the base diameter of the cone. So go for the circle option and then you just move the cursor onto perpendicular edges of the square, you get the center point. So ensure the center point is on in the IntelliSketch and you get this point. So keeping this point, now draw a circle of diameter 30 mm representing the diameter of the base of the cone. So now this is the top view of the combination of the solids, that is a cone which is resting on the cube. So we shall complete the front view. Select the line of thickness 0.13. So from each of the corners, draw the projection lines and also from the center to get the axis line, intersect the XY line. So now go for the center line and from here let us draw the combination. So here in the front view, first let us draw the cube. So the cube is measuring 50 mm. So the axis line of 50 mm initially. And next the height of the cone is 40 mm. So on top of this, draw a line of length 40 mm. So go for the line of thickness 0.50. So from here, that is 50 mm, complete the front view of the cube. So select all these lines and convert this into a continuous line. So now let us draw the cone. So select a continuous line. So this is the axis. So before we get the front view of the cone, so we need to draw the projections. So select a line of thickness 0.13. So let us draw the horizontal diameter and from here, from the end points, let us try to connect the projection lines. So use the extend to next option and extend these projection lines. Go for the line option again, select a line of thickness 0.50 mm. So from the apex of the cone, join this to the base of the cone. So this completes the orthographic projection of the combination of the solids. So go for the smart dimension, indicate the dimensions. So the height of the cone is 40 while the cube is measuring 50. So this is 50 again in the top view and the diameter of the base of the cone is equal to 30 mm. So these are the parameters that we need to consider to draw the isometric projections. So go for the annotation and annotate this line as x and y. And the planes as VP and HP. So now we shall proceed towards constructing the isometric projection. Select a line of thickness 0.13, arbitrary length, and then from any arbitrary point, draw a line of length 50 mm, so which is equal to 5 boxes in the isometric sheet, but here we will construct it using the true scale and later on convert this into the iso scale. So complete the bottom face of the cube, so 50, and the angle here will be equal to minus 150, and complete this. So a line of length 50 mm and the angle is minus 30. So from here let us draw the line of length 50 mm, that is 5 boxes in the iso sheet, but here construct 50 mm to the true scale and then convert this later into the iso scale. So now we have completed the cube. So join the endpoints of all these vertical lines to get the top face of the cube. So this completes the first solid, that is the cube which is measuring 50 mm. So on this cube we need to construct a cone whose base diameter is equal to 30 mm. So for that, let us just go for the line option, select the line of thickness 0.13. So let me just change the color for reference and enclose this top view of the circle inside a rectangle. So here the length will be equal to 30, and again 30, 30, and then complete this. So you can just see that I need to have a square first of side 30 mm. So let me just select, see, this is a square of side 30 mm. So I need to construct this blue color box on the iso scale also, and then from there I need to draw the circle. So before we do that, also let us know the distance between the endpoints. See here, these two lines it is 10 mm, and these two lines it is 10 mm. So again here and here it is 10 mm. So I need to offset this to a distance of 10 mm first. So what I'll do is, let me select the offset option, select this square, and then offset this to a distance of 10 mm. So you get to see this is 10 mm in the true scale, but in the iso scale, that is, you need to construct this square at a distance of 10 mm from each of these boxes, that is one box. Okay, so now let us proceed towards constructing the circle. So let me go for the line option again, join the diagonals of this particular square, and then let me use the 4 point center method. So from the from the corner, join the midpoints of the opposite edges, and you get the four centers: center 1, center 2, center 3, and center 4. So now let me just change the parameters: 0.50 color to black, and then select the arc by center point, and let me sweep an arc considering C1 and joining this to arc. So if this is happening, just go for this, select this line, and then sweep an arc. So let me change the parameters. 0.50 is the thickness, color is black. Similarly, select arc by center point again, change the parameters to black and thickness 0.50. So keeping this as the first point of center, sweep an arc. So this is the center 2. From center 3, let me construct an arc. Again from center 4, keeping this as the radii of the arc, sweep an arc. So you get the base of the cone. So now go for the line option again, and then select the center line of thickness 0.13. So this is the center, it is collinear, correct? So the height of the cone is 40 mm, as you can see it in the front view. So this is a line of length 40 mm. So now let me get back to the line of thickness 50 mm, 0.50 mm, and then a continuous line. So from the apex, join this to the outermost edge of the outermost point on the circle. So we do not have an edge here, so just consider a point and ensure that it is not intersecting inside. So do not make it a point here, do not join this to this point, so you will get a line like this. So it should not be done in this way, just join this to the outermost point on the base circle. So now let me just go for the split option. So this is one complete arc, and let me just split this at this point. Correct. Similarly, right click, select this, and then split it at this point, so you get these two as different entities. So let me just select this and this portion of the circle and change the thickness to 0.13, so as it is not visible to the observer. Again, here also, let me just select the split option, select this entire line, and I'll be splitting it at this point of intersection. Similarly, select this entire edge of the cube and split it here, so you get these two as different entities. Now select this portion of the cube, all the outer visible edges, and change the thickness to 0.50. So you need not have to highlight the edges which is not visible to the observer. So even if you're keeping it trimmed, even that is also good. But here, just to make you understand the construction, I'll retain the construction lines. So go to the angle between. So this is 30 degrees and this is 30 degrees again. So this is the isometric projection of the given combination of the solids. So let me just delete this dimension. It was used only for the construction purpose. So now, as per the rule, select this entire isometric projection, go for the scale option and change the scale to 0.816, because that is how the isometric projection is related to the true length. So this is the isometric projection. Ensure the copy option is off. So this completes the isometric projection. So go for the smart dimension. So you can see that the actual length was 50 in the true scale, but it is 0.81 times 50, which is equal to 40.8. So let me just unlock this and rewrite this as 50 and tell this is ISO 50. So select the annotation and enter ISO here, indicating this is the isometric dimension. So ISO 50 represents 5 boxes in the ISO sheet. And similarly, the height, you can just go here, select the distance between the apex of the cone and the center point, which is equal to 32.64, which is 0.81 times the 40 mm, that is the true length. So just unlock this, rewrite this as 40. So the underlined symbols, it is representing that it is the overwritten dimension and not the actual dimension. So again, I'm placing ISO here, indicating this is the isometric height of 40 mm. So that is 4 boxes in the ISO sheet. So with this, we complete the orthographic projection of the given combination of the solids, that is a cone resting centrally on the top face of a cube with both their axes being on the same point. Thank you all for watching.